Okay. So scatterplots, they are the best way to study the relationship between two quantitative variables. And time plots, they just show trends over time. Something about both of these though is like they look very similar when you see them. All right, so the drawing scatter plots to match the conditions. What would, or well, here, I'm going to draw my little plots to get ready first. What would the first one look like?
Oh, we wrote these down. Oh, wait, no. Last we did. Okay, so little or no association. So isn't that just like kind of everywhere?
Spread all over the place.
Okay, so okay, so negative is going this way.
Yeah.
And so if it was moderate, that means that it would kind of be spread out, but like not really. Like it's not strong or weak, so it'd be kind of in between. I don't know how to describe that.
A little bit spread out, but still you can tell that it's more or less in a line. How about strong nonlinear association?
So then they'll be really close together, but okay, so if it's non-linear, that means it's random or curved.
So if it's strong, I would say probably more of a curve.
Okay, so it doesn't say that it's positive or negative. How do you know that it goes in that direction?
It doesn't have to. It's just non-linear, so it doesn't. I mean, if it's non-linear, they're not necessarily going to tell you positive or negative. All right, which variable is the explanatory variable? The x, which is the independent variable. Also known as the predictor variable. Which one is the response variable? It's the y, and it's also known as the dependent variable. All right, so suppose you were to collect data for each pair of variables. You want to make a scatter plot. Which variable would you use as the response variable and why? And then what would you expect to see in the scatter plot? Discuss the likely direction, form, and strength, and draw a picture to represent the scatter plot.
Okay, so the number sold would be the dependent, and then the price would be independent.
Yep. So price and number sold.
So it would t-shirts have store price.
So as price increases, what do you expect to see in the number of t-shirts
Less
sold?
shirts.
So it has what kind of a relationship? If his price increases, you see less. It's going to be positive or negative?
Positive. Lies. Negative.
Negative. So negative. Think linear, curved, or completely random?
Linear.
Linear. And you think strong, moderate, weak, no?
Probably moderate. I would say.
Moderate. So it looks something like a little bit spread out, but you can still see there's a pattern to it. All right, the next one. All elementary students, their weight and score on reading test.
So this is definitely gonna be no association or little to no association. At least I think.
Why?
Because you got some students that are smart, some that are stupid. So you got it's
And their weight can be anywhere. Like, it's hard to compare their weight to the test score.
you have
Like, how do you do that?
like chubby kids, skinny kids. That's
Could be all over the place. Seagull laugh.
It's talking about the weight of the test.
Weight, and I was like, how do you compare those?
He was like, well, you got some chubby kids.
Yo, I thought it was something like the way the student.
Okay, that makes so much sense. Okay, I need you to crop that in the video.
Ow.
Weight of test. Okay.
I get them every year with that one, and it makes me laugh every time.
That's funny. Okay, so it's the weight of the test instead of the weight of the kid.
So what's the independent and dependent?
Okay, so the weight of the test, or the score is dependent on the weight.
So weight, and then score on the test. That was amazing.
You got chubby kids, you got skinny kids. And in between. Kind of all over the place.
However, if it was the weight of the kid, there would be no
No.
correlation.
That's kind of funny. Okay,
Whew.
so,
All right, what kind of relationship is it?
Well, I would probably say positive.
And this is just like the likelihood of it being positive, right? Instead of like it actually being positive.
Yeah, it's just what would you think based on this information? What do you think would happen?
It'd probably be linear again. And moderate.
Moderate. With something like this, you could theoretically have outliers. I mean, you could always have outliers, but
We got that one kid that's like
Super chubby and he does really good on his test.
highlight of the day right there. All right, what is correlation?
It's like the strength of a linear association, like between two variables.
Strength of linear association. Between to, and specifically quantitative variables. Apparently state rankings just came out.
Oh my gosh. Brief pause.
Oh wait.
We best be number 1 in D4.
Oh wait, they're not out yet. But the team that we played last year just got moved up to 3 instead of 4. All right. So what does the correlation coefficient have to be between?
+1 and -1.
If the absolute value of R is close to 1, what does that mean?
If it's close to 1,
Yeah.
it's strong.
Strong linear association. And if it is approximately 0 or close to it, it would be what?
Weak.
Yeah. No or weak association. And then I would say I'm going to go ahead and put this here just for the purpose of our stuff. If it is plus or minus like 0.8 or above, we would say it is strong. If it's plus or minus 0.2 or below, it's weak. And then anything in between is going to be moderate.
Plus minus negative
0.8. And then 0 is going to be no. That's just kind of like a good, just like, there's no written rule that says that has to be what it is, but that's typically, if you see how the book would describe it, that's typically how they're going to describe it in those ranges. Now, I mean, if you get like 0.75 and you tell me it's strong, like, I'm not going to like take off for that, you know what I mean? But like, that's just kind of the good rule of thumb to go off of. All right. Number 3, draw a scatter plot to represent the following correlations. So we're going to have
So this will maybe a strong linear association.
in what direction? Positive or negative? Strong, negative, linear. So everything pretty tight together there. What about the next one?
Be moderate, positive, linear.
Moderate, positive, linear. And sometimes, I'll just put this up here, sometimes the book will call one like this moderately strong. So if you see that, and if it's getting closer to the 0.2, they may say moderately weak. Just more of a FYI. So, gonna be, I would say still kind of close together, but a little bit spread out for the moderate part. And what about the last one?
Weak,
Weak or no, because it's getting close to 0, but positive. And if it's weak or no, it's not going to be linear because it's going to be pretty spread out.
Okay,
It's just nothing. It's just, well, I guess you could classify it as random. If you really wanted to, we could call it random.
So it's weak, not positive.
Like weak or no correlation. So really, if we're going to say it's random, I guess we really shouldn't say it's positive either, technically, but it is a positive number, so if you left it, I wouldn't take off for that. All right. So the next one. Antidepressants. A study compared the effectiveness of several antidepressants by examining experiments in which they had passed FDA requirements. Each of those experiments compared the active drug to a placebo, an inert pill given to some patients. In each experiment, some patients treated with the placebo improved, a phenomenon called the placebo effect. Patients' depression levels were evaluated at the Hamilton Depression Rating Scale, or on it, where large numbers indicate greater improvement. The scatterplot below compares mean improvement levels for the antidepressant and placebos in several experiments. That was a mouthful. All right. So, is it appropriate to calculate the correlation? In terms of like what things are we looking for to see if we can use the correlation? There were like 2 or 3 things we wrote down that we said had to be.
Whether it's weak or strong.
Well, that's not one of the ones to say if we can do it or not. What do the variables have to be? What kind? Categorical or quantitative?
Quantitative.
Quantitative. So are they quantitative variables?
Yes.
Placebo improvement on the Hamilton scale, and then, what does that say? Drug improvement on the Hamilton scale. So both of those are quantitative, so that's good. And then is it linear?
Yes.
Okay. So those 2 things, so it would be yes, because we have quantitative variables and it looks linear. Now, the reason that this point up here kind of has a circle around it is because this would be a possible outlier just because it's so much away from the line of the rest of the data. Okay, can't say for a fact that it is, but that's why when I imported it, it kept half the circle. So the correlation is 0.898. Explain what we have learned about the results of this experiment. So what does that correlation tell you?
That it's positive.
What would we classify this as? Strong.
And then
So positive, strong, linear association between placebo improvement and drug improvement. And so just kind of a little bit more as to what that would mean. If the patient shows strong improvement with the placebo, they're likely to see an improvement. With the drug. All right, so cellular phones and life expectancy. A survey of the world's nations in 2004 shows a strong positive correlation between percentage of the country using cell phones and life expectancy in years at birth. Does that mean that cell phones are good for your health?
Well, if it's positive, then so the cell phones are dependent. I mean, your health is dependent on the cell phone, so you're dependent. It's positive.
So do y'all remember what I said in the notes last week at the end, or close to the end, and I said this is a common thing where people say this is a result of this.
No causation.
Correlation does not equal causation.
Gosh, dang it.
So, no. Countries with a higher percent of cell phone use oh my goodness, what is happening? Also tend to have a higher life expectancy. But the big thing here is that correlation does not equal causation. What might explain the strong correlation?
How many people have cell phones? I have no idea.
How do I put this? What kind of countries tend to have cell phones?
United States. I mean, ones with a.
Would you expect the Sahara Desert people to have cell phones? So, what about, like, I'm trying to think. I'm bad at coming up with countries. I was really bad at geography. Okay, so, like, third world countries, would you expect them to have cell phones overall?
Countries that are richer, I would assume, would have more cell phones.
Yes, so the strong correlation, we could say that the wealth of a country impacts the percent of cell phone usage and life expectancy. Because even if you go over, like, to Africa and you see, you know, like, all the people that are, you know, they had, like, the Zika virus thing and all of that, like, again, a wealthier country is going to have things to help fight those things, which are going to increase life expectancy. I don't know if that makes any sense at all, but so what we could say is that wealth could be a lurking variable. Not necessarily mentioned, but definitely could be playing a part in what's happening. Well, I just realized one of them's actually on there twice, so.
Oh, sweet.
Oops. Number 7 is the one we just did. I always forget to go fix that. Oops. All right. Conditions to check before doing a linear regression. So we kind of mentioned those a minute ago, but variables must be quantitative. Scatterplot must be linear. If there are outliers, then we need to give the correlation with and without the outliers, so we know how much it really affects it. All right, so roller coasters. Roller coasters get all their speed by dropping down a steep initial incline, so it makes sense that the height of that drop might be related to the speed of the coasters. Here's a scatter plot of the top speed and largest drop for 75 roller coasters around the world. Does the scatter plot indicate that it is appropriate to calculate the correlation and explain?
Yes. Because it is linear and quantitative.
Yep. And
the outliers.
maybe not. These couple points up here possibly could be outliers. They're a little higher up there, but don't know for sure. So yes, and I'm just gonna put conditions met. In fact, the correlation of speed and drop is 0.91. Describe the association.
Positive, strong, linear.
Positive, strong, linear. I should say relationship between the initial drop and the speed of the coaster. Coasters with a larger initial drop. Tend to have faster speed. I'm gonna skip 8 and come back to it tomorrow when we have more time. We'll go to number 9, and if we have time, 10. We'll do 8 and 11 tomorrow. All right. Owners of a coffee shop tracked sales for the first 20 days and displayed the data in a scatter plot by day. Make a histogram of the daily sales since the shop has been in business. Okay, so we have days here, sales in dollars. So just to check quantitative variables, this isn't a scatter plot, so it's not linear, but anyways, quantitative, not necessarily outliers, so anyways. These numbers here are how many of each day we had at that amount of money, just so that you can see it. This would be something you would have had to write in yourself, but it was just on the picture, so I just copied it over. So all we're going to do is basically we're taking this and we're going to flip it to make a histogram. So we're going to have frequency, and we're going to have sales, 100, 200, 300, 400, 500, 600. So how many days each that we had in there? So the frequency is how many days? So I'm going to go up to 8, 2, 4, 6, 8. So $100 days, we had 2 of them. $200 days, we had 4 of them. $300 days, we had 8 of them. $400 days, we had 4 of them. And $500 days, we had 2 of them. So obviously my things aren't exactly equal, but close enough. Symmetric. State one fact that is obvious from the scatter plot but not the histogram.
The dates. That's not what that's for.
But that's not really what it was. I can answer C.
What do you notice about the sales as the days have increased from day 1 to day 20?
They go up and they go down.
So I mean, you start out over here, you got some $100 days. Your initial day is 300, but grand opening day kind of thing. But it progressively is going up. I mean, once you get out here, you're not having any more $100 days. You're progressively getting higher, up to $300, $400, $500 days. But you wouldn't be able to see that from here. You would just be able to see how many total days you had each thing. So the trend is that sales are increasing over time. All right, you said you got C, Ethan, so what'd you got? Symmetric, and what else?
Unimodal.
Sales are symmetric and unimodal. And what's the most frequent amount of sales that you had?
Most frequent amount of sales?
Yeah. Huh? Yeah, the $300 days. So, I mean, yes, you could technically see that from the other one. You can count them, but I just wanted to point that out. All right. I think we can get in 10 really quick. All right. A polling organization is checking its database to see if the 2 data sources it used sampled the same zip codes. The variable data source 1 is equal to 1 if the data source is Metro Media, 2 if it's Data West, and 3 if it's Rolling Poll. The organization finds that the correlation between 5-digit zip codes and data source is minus 0.0229. It's supposed to say concludes that the correlation is low enough to state that there is no dependency between zip code and source of data. Comment about this.
Okay, well, the correlation is negative. So, I really want to.
What do we know about correlations, though? What conditions have to be met?
It has to be quantitative data.
It has to be linear, and it has to have an outline. One doesn't have
but if you have them, you've got to note them.
Yeah.
So what do you notice about these variables?
It is quantitative. Oh wait.
Zip code's quantitative?
The zip code is not quantitative.
It's
Categorical. Gosh dang it.
So they actually both are, because they're numbers referring to something. Both variables are categorical. So we cannot find a correlation. Or draw a scatter plot.
Realize that, like, the zip code is categorical.
But that's the thing of you got to make sure you check those, and that's why, because sometimes they'll give you something that's not actually the conditions that you have to have. More often than not, if they give you a list of data, it's going to be, but ones like this, they're going to try to catch you every once in a while.